Good morning, OLC Middle School students. This is Mr. Woolley. Remember, the information contained in this video is intended to be viewed only by the students in Mr. Woolley's classroom. By watching the video, you agree that you will not record or share the video with anyone who is not a student in Mr. Woolley's classroom. Okay, lesson 2 today is about generating equivalent expressions. Now, the first little page here, they have some introduction here to you, is like when you have a number and its opposite, how they always add up to 0. Most of these are pretty simple. You can kind of view those and look through them. If you have an x, the opposite of that would be a negative x. And if you have a 3x, the opposite of that is negative 3 times x. If you have x plus 3, that's some quantity, you can put parentheses around it and make it negative x plus 3. Now, if that's the case, remember that negative applies to everything in there. So negative x and negative 3 is how that would kind of play on out. And 3x minus 7, the opposite of that would be a negative of that grouping, which turns into negative 3x. Now the opposite of a negative 7 would be a plus 7. So notice how the opposite now would be a negative 3x and then a plus 7. All right, at the top of the next page, just a simple addition one for you. You got 40 plus 9 in parentheses. You got 30 plus 2 in parentheses. 49 minus 32 gives you 17. Now, when it comes to working with like terms, this is where we have to really focus and pay attention. I have an x plus a y minus a regular number. Minus, I have an x number and a regular number here. So what I got to do is x's can be dealt with x's, y's can be dealt with y's, and regular numbers get dealt with regular numbers. So I have a 3x here minus, notice how there's a minus sign there, a 4x. 3x minus 4x gives you a negative 1x, or what we'll just call negative x. Now the y's, 5y minus, there's no other y, so 5 minus nothing is just 5y. And then I have a minus 4, what I'm going to treat as a negative 4, minus 11. So negative 4 minus 11 gives me a negative 15. So altogether, all those pieces, when I collect like terms, is a negative x plus 5y minus 15. All right? They want us to do this vertically now. So they line up the A's, the B's, and the C's on top of each other. And it's this chunk plus this chunk. So 5A plus 2A gives me 7A. 3B plus a negative, or just minus 4B, gives me a negative 1 of the B's. And then a minus 6C, which I'm going to treat like a negative 6C, plus a positive, so just plus 13C. A negative 6 plus 13 gives me 7C. All right, now remember, as we work on this grouping, I have this first grouping minus this grouping. That minus is going to kind of turn everything into its opposite. So 2x minus a 5x. 2x minus 5x. 3y, and there's no other y, so 3y minus nothing. Negative 4, that's a minus a 2. Negative 4 minus 2. So 2x minus 5x gives me negative 3x. 3y minus nothing is just 3y. Negative 4 minus 2 is negative 6. All right. We have a word problem over here for us on page 9. It says a stick is x meters long. A string is 4 times as long as a stick. Express the length of the string in terms of x. Well, the stick, I don't know how long it is, but they said it's going to be x. The string is 4 times as long as that, so 4 times whatever x is. 4 times x. So the string's 4x meters long. Now down here in B, if the total length of the string and the stick is 15 meters long, how long is the string? Well, we said the stick was x and the string was 4x. Together, those are supposed to make 15 meters. So x plus the 4x equals 15. So add them together. If there's 1x here plus 4 of them here, gives you 5x's. Now, if I want to get rid of that times 5, I divide by 5, divide by 5, I'm left with x equals 3. Now remember, that's the stick. If I want what the string is, I need to do 4 times whatever x is. So let's look at our explanation. The stick is 3 meters long. If the stick is 4 times as long as the stick, then 3 times 4 gives me 12. So the string is 12 meters long. You can always double check your work. 12 plus 3 does give us the 15 they said was the total. All right, example 4. It costs Margot a processing fee of $3 to rent a storage unit, plus $17 per month to keep her belongings in that unit. Her friend Carissa wants to store a box of her belongings in Margot's storage unit and tells her that she'll pay $1 towards the processing fee and $3 for every month that she keeps the box in storage. Write an expression in standard form that represents how much Margot will have to pay for the storage unit if Carissa contributes. Then determine how much Margot will pay if she uses the storage unit for 6 months. Now, when they say standard form, it means like just get all the like terms collected, so kind of clean up your expression. Now, if Margot is going to pay it by herself, it's $17 per month, so 17M, plus that $3 processing fee to sign up and do the paperwork and get her key and everything. Now, Carissa, though, if Carissa wants to help out, she'll take away $1 out of the processing fee, and it'll take out $3 a month out of Margot's money also, because Carissa's going to pay $3 a month. So now, what Margot is going to pay if Carissa contributes, $17 a month minus $3 a month means she's only going to pay $14 a month. And then the $3 fee, one gets taken away from that, so now it's only $2 for the fee. So 14M plus 2. So now, you can use this expression, because if she wants to use it for 6 months, 14 times 6 gives you 84, plus 2 gives you 86. So Margot will pay $86 if she uses the storage unit for 6 months. Thanks to her friend helping her out a little bit. All right, and when we get to our next page here, there's a few examples to look at. What they're talking about is what number you're given, and then the multiplicative inverse of that. All right, now the multiplicative inverse is like the flip that we do with when we would divide with fractions, or a reciprocal, you might used to call it. So 3, if you flip it, it's 1 over 3, because technically any whole number is a 1. So you put 3 over 1, flip it to 1 over 3. All right. Now, if you multiply those out, 3 over 1 times 1 over 3, you just get 1. All right. And if you divide that, 12 divided by 3, for example, well, 12 or 12 over 1 times 1 over 3. So they flip that. And you get 4. All right, so here's another example. You're given a 5. The multiplicative inverse of the flip of that is 1/5. Now, if you take 5 over 1 times 1/5, you just get a 1. You get the same thing. Now, if I did this, 65, or what we call 65 over 1, divided by 5 over 1, and make it 65 over 1, because I keep it, change the times, and I flip it to 1/5, and I get 13. So, similar kind of concept as you can kind of see in these examples here. I'm not going to go over every single one of these by any means, but one of the ones I did want to look at with you was down here. The opposite of x, or it's not opposite, the multiplicative inverse or reciprocal of x, if you put x over 1, becomes 1 over x. And if you have x over 1 times 1 over x, you get x over x. So anything on the same top and bottom is 1, same numerator and denominator. Now, how does this work over here? If you took 5x divided by x, so I got 5x over 1, change to times, and I flip it to 1 over x. I get 5x if I multiply across the top, and I get x in the bottom. But when you have x's on top of x's, the x's divide each other out essentially. You're left with just a 5. Same kind of concept happens here. I got 2x, or 2x over 1, so I flip it to 1 over 2x. And of course, if I times those together, I get 1. But if I had 12x divided by 2x, well, 12x is over 1, change the division to times, and then flip 2x over 1 to 1 over 2x. So keep, change, flip like we always do with division. And at that point, the x's divide each other out. You're left with 12 divided by 2, which gives you just a 6. So you'll see some more of that on part 2 of our lesson. All right, so now the last examples of the day I want to kind of point out is how to work with some of these, get them collected into standard form, so collect like terms, get them in standard form, and then solve using a given value. For this top group, they want us to use x equals 5. So if I got 3x plus 2x, sorry, 3x plus 2 minus 4x, well, get the parentheses out of there, it ends up being 3x plus 2 minus a 4x. Well, 3 minus 4 gives us a negative 1 of the x's, and then there's no other numbers other than the plus 2, so just the plus 2 attaches there. Now, if x is supposed to be a 5, a negative x becomes a negative 5. A negative 5 plus 2 gives me a negative 3. Over here, I have a negative 3x plus just a 2, and then plus a 4x. Now in this case, a negative 3 plus 4 gives me a positive 1 of the x's, And that plus 2 is just all by itself. There's no other numbers there, so x plus 2. X is still going to be a 5 for this set of problems. So 5 plus 2 gives me 7. All right, now I have 3x minus, I'm going to take away everything that's in here. 3x minus 2, 3x minus the 4x also. So this is 3x minus 4x gives me a negative x. This time I got a minus 2 attached with it. So a negative x, well, if x is still a 5, becomes a negative 5 minus 2 gives me negative 7. Over here, I have 3x minus, everything you see in here. It's 3x minus a negative 2. Remember, add the opposite, ends up being a plus 2. And 3x minus a 4x is just a minus 4x. So 3x minus 4x leaves me with a negative x. And there's just a plus 2 hanging around there, so I got a plus 2. Well, negative x, if x is still 5, becomes a negative 5. Plus 2 gives me a negative 3. And a couple more here down towards the bottom. These ones have different values every time. I got 4y minus, then I got 3 plus y. So that becomes 4y minus 3, and then minus this y. Well, 4y minus y, it leaves me with 3y's. I always try to have the letters out front first. And then there's no other thing other than the minus 3, so minus 3. 3y minus 3. Now, if y is supposed to be a 2, well, 3 times 2 gives me 6. And minus, on that one, I get 6 minus 3. That should actually be 3 on that one. So 3 times 2 gives you 6, minus that gives you a 3. So a little goof up there on my part. I make mistakes too sometimes. All right. And let's shift over to b. I got 2b plus 1. And I'm supposed to take away a b from there. So 2b plus 1 minus 1 of my b's. So 2b minus b gives me just a single b. And that's still plus 1 just all by itself, so it's the plus 1. So if just a single b, b is negative 4, it becomes negative 4 plus that 1, and it gives me a negative 3. And last example of the day here, I got 6c minus 4. I'm supposed to take away everything you see in this group, which becomes 6c minus 4, and then minus that c. Now minus a negative 3 becomes a plus 3, because remember, add the opposite. So I get 6c minus c leaves me with 5c, and negative 4 plus 3 leaves me with a negative 1. So 5c minus 1. You know, c is supposed to be a negative 7. That means 5 times a negative 7, which is negative 35, minus 1 gives you negative 36. So go ahead and give your practice a try in Schoology. Good luck.